a derivative can be described as the slope of a tangent line on like a function. So for example, you're given f of x, right? Say f of x is equal to 2x squared plus ax plus b, and you want to find a and b. Oh, and the parameters that you're given are like f prime negative 1 is equal to 2, and then it passes through 0.16. This is your x and y value. Essentially, this, I forgot, laser pointer, yeah. This thing is like f prime negative 1, which basically just means like the derivative where x is equal to negative 1. So, when you come across a question like this, you kind of want to start, my math teacher told me, always take the derivative. If you're ever stuck in a calculus question, take the derivative and you'll get like at least 1 mark, because you probably have to take the derivative anyway. So we're going to take the derivative of it. We're going to find f prime, why are we in a different color? We're going to take f prime of x, which is, you're going to apply the power rule. So the power rule, essentially, I should have explained this before, but you see this 2x squared we have there, right? So if we want to apply the power rule for this, what we want to do is you want to take this, the exponent, multiply it with the coefficient if there is one, and then subtract it by 1. So essentially what you're going to be doing here is 2 times 2, which is 4. So your coefficient is going to become 4. And then the x stays there, but then your 2, it loses a 1, so it just becomes 4x to the 1, but you can choose not to put that there. Yeah, so your 2x squared becomes a 4x, and you can basically apply that anywhere. But yeah, so we're going to have 4x plus a, and a, we get a because there's an invisible exponent of 1, you're multiplying a times 1, it's still a, and then you're removing that exponent, so it becomes x to the 0, which is 1, which is why we omit that. And you see this b over here doesn't have a x attached to it, so that means this is a constant, and constants, when you take the derivative of any constant, it's always 0, so just remember that. You can omit that from the equation now. So you see now we have this formula, which can help us a lot. So now you see this is just basic problem solving. Now we're given this parameter where f prime to the f prime of negative 1 is equal to 2. So we can write it like this, negative 1, and then replace every x in the equation with negative 1, which isn't that big of a problem, there's only one of them, like that. And since that is equal to 2, we want to make this equal to 2, and this becomes negative 4 plus a. And now we have a, when you add 4 to both sides, this becomes 6. So we have a equals to 6 now. And if we want to find b, we have to sub in this point over here. Okay, so we want to sub that into the, what do you call it? Yeah, you want to sub it into the original function, I believe. Yes. So you take the y value is equal to f of x, and then 2 times 1 squared plus, now you know it's 6 times 1 plus b, you can find b now. 6 is equal to 2 plus 6 plus b, so b eventually equals to negative 2, if you add that right. So yeah, that's how you find your a and your b. That was kind of a messy way of solving it, but yeah, that's essentially what it is. So, if you ever come across a situation where you're given the derivative of, well, okay, I'm just gonna write it down. So say you're given f of x is equal to ax3 plus bx squared plus cx plus d, and you're given that f prime of 0 is equal to 0, you're given that f prime of 1 is equal to 5, and you're given that f prime of 2 is equal to 16, and then you want to find f prime of 3. So what is that? Okay, essentially what you're going to do here is you're going to take the derivative, as always. So, okay, we'll go up there now. It becomes f prime of x is equal to, you multiply that 3 down there and then remove 1, so it becomes 3ax2 plus 2bx plus c. And now that d doesn't exist anymore, so, because it became a 0. And now we have to make use of the information that we have. So we have, oh my god, shut up. Okay, sorry. We can put in the 0 now. So let's say f prime of 0 is equal to 0, right? You don't exactly have to sub this in, because if you just look at it, you can figure it out, right? This has an x, this has an x. So if x is 0, these two will both be gone, leaving only c. So that means c is equal to 0, if that is the case. So c is equal to 0. And now this kind of helps you set up to be able to find everything else, because now you know c doesn't really have to be here. Technically it doesn't, so yeah. So now you want to put in your 1. So f prime of 1 is 3a plus 2b, because you don't have to worry about c anymore. And now you have this equation, right? And you know that that is equal to 5, so 5 is equal to 3a plus 2b. You have this equation. This is going to come in handy for you later. And then now you want to take the f prime of 2 equation. This is really bad form, but it's okay. I'm not being graded on this. So now this is 3a times 2 squared plus 2b times 2. So that becomes, that's 4. 12a plus 4b is equal to 16. Yeah. And you kind of want to simplify this so that at least one of these terms corresponds with one of these terms, so you can eliminate this. So when you look at this, you can divide everything by 4, essentially. So this becomes 4 equals 3a plus b. And you can see that there's a 3a here and there's a 3a here, so now you can eliminate. Yes, these are your 2 equations that you're going to eliminate, by the way. So you're going to have a 3a plus b is equal to 4 on the top. Oh, no, wait, sorry, I should put the other one on the top. 3a plus 2b is equal to 5 minus 3a plus b is equal to 4. when you eliminate this, the 3a's cancel out. 2 minus 1 is 1, so b remains, and this is 1, so b is equal to 1. Now you have your second letter, and you can sub this value back into any one of these equations. So I'm just going to do that one real quick. Oh, sorry, I circled the wrong thing. I meant this. Yeah, what's the point of even circling it for myself if I don't remember? Okay, so then you get, if we're using that one, we can do 5 is equal to 3a plus 2. 5 minus 2 is, or 3 is equal to 3a, and so consequently a is equal to 1. And now you have all your letters. Exciting. Okay, what's next? What else can we do? Oh yeah, just like a application of the power rule, if it's not familiar yet. Say you have g of x is equal to 4 to the, I don't really know how to say this, but that, times pi to the, whatever this is, minus 2 to the 3 pi. So, this stuff corresponds to an exponent, so you always have to remember that. It's better if you have exponents, so don't leave things in roots. That corresponds to 4x 3 over 4 multiplied by pi x 1 over 5 minus, 2 to the 3 is 8 pi. And you can kind of expand that in, distribute it, so that it becomes 4 pi, and now you want to add, use your exponent laws, add these two exponents together because they're being multiplied. It will give you 19 over 20, and then distribute that in, it becomes minus 24 pi x to the 3 over 4. And, okay, oh, sorry, not 24, what am I saying, 32. Yeah, pi x to the 3 over 4. And now this is your simplified, okay, this is not your derivative yet, this is still g of x. Okay, but if you want to find g prom of x, now you can start applying your little rules. So 19 over 20 times 4 pi will give you 19 over 5 pi x, and then 19 minus 20 minus, no, sorry, 19 over 20 minus 1 is negative 1 over 20. And then multiply this with that, you get 24 pi x to the negative 1 over 4. And then this is your final derivative. That's a really bad square. But yeah, that's essentially what you have here. We don't have to do this. Yeah. Okay. This is some, like, really vital parts to know about derivatives that, you know, I'm doing for my own good. Okay, so let's do this in a different color because this is prominent, okay? Product rule is one of the big ones. Okay, basically, when you have, oh, I forgot the rule, okay? Basically, when you have a function, say p of x, right? And it's equal to a function times a function. So f of x times g of x, right? So if you see a situation like this, you know, use product rule. Essentially, the product rule states that the derivative of p of x is equal to the derivative of the first term times the second term, and then this plus the derivative of the second term times the first term, regular, like that, okay? It looks kind of funny, but the application is simple enough. So say, I'm going to go back to blue. Say you have this function, f of x, is equal to x to the 3 minus 2x, and then 3x to the 4 plus 2x plus 8. Okay, so these are your two functions, okay? This is one function. This would be your f of x. Well, in this example, maybe you should have used a different variable there, but it's whatever. And then this is your g of x. So to make this simple for yourself, you should probably find the derivative of each of these first before actually calculating it. So the derivative of your f of x, which I'm going to do in purple, is going to be 3x minus 2. Oh, cute. Oh, that's really bad, but that's okay. And then your g of x is going to be 12x to the 3 plus 2. That's much better. Okay, so now you're going to apply the product rule here, right? So you're going to take the derivative of the first one, so that'd be 3x minus 2. 3x minus 2, and you multiply it with the original, plus 2x plus 8. This is your first thing. This corresponds to that. And then you add the derivative of the second one. So this is 12x 3 plus 2. And then you multiply that with the original here. So x cubed minus 2x cubed. Okay, it's essentially like this. And now you expand. I really don't feel like expanding this right now, but you should get a final answer of x to the 6 minus 30x to the 4 plus 8x3 plus 24x2 minus 8x minus 16. So this is what product rule is, essentially. Let's box that up. Is it going to mistake it for a triangle? Nope, not today. Okay, that's really important. And then another thing you should know is quotient rule, which we can probably do on the next page. Okay, quotient rule. Yeah, essentially, it's in the name. If you have a function divided by another function, so say p of x again, right, is equal to f of x over g of x. So what you want to do here is, when you're taking the derivative of p of x, it's going to be the derivative of f of x times the regular g of x, that minus derivative of g of x times regular f of x, and then you want to divide that. Okay, so the top is basically the same thing as product rule, except it's a minus instead of a plus. And then at the bottom, you want to take g of x and, oh, oops. Okay, good. Take g of x, and you want to square it. That's the main difference. It's no biggie. So say you take an example here. Say you have g of x is equal to f of x. Oh, I guess this isn't really like a super simple question, but it's fine. You can do it. You have that function where f to the 5, not f to the 5, whatever, that is equal to that, and f prime of 5 is equal to negative 5. And then you want to find what g prime of 5 is. Good question. Okay, so we're going to product rule this thing. Different color. Yeah. So g prime of x is going to be f prime of x, bracket x minus 1, that, minus, put it in brackets, minus the derivative of root x minus 1, which would be half x minus 1 to the negative 1 over 2. This is multiplied by f of x. I should put that in brackets. F of x. And then all of this is over x minus 1 squared, which is pretty much just x minus 1. Yeah. So now that you have this, you can put in the 5 because they tell you what these values are. So if you were to have g prime of 5, which is what you're trying to find right now, you can have f prime of 5, which is a value that we're given. We're going to check that later. And now we have 5 minus 1 underneath the root. And you still have this 5 minus 1 again to negative half, and then times 5 f to the, not f to the 5, f of 5. And this is all over 5 minus 1, which is 4. So looking back at the values we have here, 5, it's negative 5. So negative 5 times, okay, this is 4, root 4, so it's 2 minus, okay, this is half times, this is like half times. Oh, right, half times 4. We can just keep it like this for now. Times, and then f of 5 here, you can find here is 8. So this is times 8 over 4. Negative 10 minus 8 times half, because that's what it simplifies to. You have 4, then your final answer should be negative 3 after all the simplification. So you have g prime of 5 is equal to negative 3. Very cool. Okay. Now we get into the sort of nitty-gritty, my least favorite thing, chain rule. You know, it's bad when you have like a product rule or like a quotient rule nested within a chain rule, but this is basically a function within a function. So p of x is now f of g of x. There's probably a better way to write that. I should do that with square brackets. Ah, go away. No, go back. Please. Okay, whatever. There we go. So f of g of x. So any x value in the function of f of x turns into g of x. This effectively. Yeah. So this applies to situations like this. So you can take an example here. Also not the easiest example, but like this is for myself, not for anybody else. I sound kind of crazy right now. But you have f of x is equal to x squared minus 3 over 3 minus 5x to the 1 over 3. Okay, so see how this is, okay, wait, this is a function. Okay, this entire thing. So imagine, let u be that. I'm not gonna write that out loud. Okay, imagine this is just a letter, okay? Imagine this was f of x equal to u to the 1 over 3, okay? How would you derive this if it was just like this? Well, you would do 1 over 3 u, and then it's 1 over 3 minus 1. Is it? Yeah, it's negative 2 over 3. Whoops. Negative 2 over 3. That's what it would look like, okay? But it's different here because you actually have a function in here. U itself is not a function. So anyway, this is essentially what it kind of looks like. But we're not doing that right now. We can ignore that. So here's how to look at it. What is the derivative of the inside here? Well, this is a quotient rule. This is something I was talking about. It's like a nested quotient rule within a chain rule, which is very stupid, very dastardly. Okay, so we are going to find the derivative of this thing first. So we have the upper function, 2x times 3 minus 5x, very quickly. Bad form too, but it's okay. X squared minus 3 times negative 5. And then, oops. And this is over 3 minus 5x squared. And then, okay, essentially this is going to turn into this big thing, negative 5x squared plus 6x minus 15. You can pause this and do this if you want, but I'm not going to waste my time. Okay, it's going to end up looking like something like this. Okay, so this is like one of your first steps. Okay, this is going to be the derivative of your inside function. But like I just showed you before, right? Imagine this was u. So then f of x would be u to the 1 over 3. And what do you do with that? You do 1 over 3 u negative 2 over 3. I don't know why I erased that before. And this is essentially your u, okay? What am I saying? I didn't even give you the rule for this. Gosh. How rude of me. Okay. This is actually p of x is equal to f prime g of x. So the function of that, this is essentially this, times the derivative of g of x. So yeah, that makes a lot more sense. This is your g of x, and then this entire thing is your f of x, essentially. Yeah. So yeah, back to where I was. Yeah. So this is going to be your outside. And this is not u, by the way. Like, this is not u. I don't know why I said that. That's the derivative of u. It's u prime, which is a very different concept. So we're going to apply the chain rule here. Your f prime of x is equal to, so you take the thing down, and then you put that in as u. So x squared minus 3 over 3 minus 5x to the negative 2 over 3. You took the derivative of that. Now you're multiplying that with this, because that's the derivative of your inside function. So now you have that plus that over 3 minus 5x squared. So this is essentially your chain rule. This is what you'll be ending up with, which is disgusting, by the way. I hate chain rule, but it's okay. We can't always have what we want. Here, let me draw a line between. Did my apple? Okay, no. There we go. Good boy. Okay. Yeah, we can do another one of these because I suck at this. Okay, so sometimes you might get a situation where you're given f of x is equal to u squared plus u minus 1. So they don't like actually sub it in for you yet. And they give you that u is equal to x squared minus 2 root x. And that you want to solve for x at 1. Okay, so what do you do here? This first chunk, this part is a chain rule. You see, because this is the outside function, this is the inside function. U represents the inside function. So you want to deal with that nitty-gritty first. So you can choose to sub this in directly if you want, but yeah, I don't know why you do that. You know what? Yeah. So u prime is 2x minus x to the negative 1/2, because that's the function. So if you want to solve for f prime of x, that would be 2 times the regular inside function, x squared minus 2 root x. And then you have to multiply that with the derivative of the inside function, so 2x minus x, negative 1/2. And then plus x squared minus 2x, which is the original function, minus 1. And then you are going to end up with an equation that looks like this. And then this is essentially what your chain rule looks like. So at this point, you can sub in 1 to find whatever you need to find. So f prime of 1 is, okay, 1 minus 2. That's 2 minus 1 plus 1 minus 2 minus 1. So when you sort this all out, it becomes x, oh, sorry, not x. It becomes f prime of 1 is equal to negative 1. And then, yeah, that's essentially what you have, which is a little bit stupid if you ask me. And now, there isn't much, oh, I should add a page before getting into those types of questions. Do I click this? No! Oh, this. Gosh, what a genius. Okay, so these are very quickly kinematic derivatives. So if you've taken physics before, this is probably not news to you, but here, let's just write that. Okay, so you have s of t, and this represents position. So the location of an object at time t. And so in physics, it would be, oh, I did not mean to do that. Okay, so your initial position would be s at 0. That'd be your initial position. Okay, and then you'd have s at t is equal to 0, and this means that object, your object that is moving, or still, I guess, is at origin. Great. But if it's s of t is greater than 0, the object is to right of the origin. So this is essentially to visualize it. Say you have a graph, right? That's really bad. You have a graph like this, and then your origin is here, right? Oh, shoot. And so if your object is greater than 0, this is 0, right? So if your object is greater than 0 to positive infinity, then your object is going to be to the right. You know, never eat shredded wheat. Right is the east. I don't know what I'm saying, but that's essentially the logic behind it. And so, consequently, this is object to the left. And, okay, this is all for position. And so the derivative of position will be velocity, so the speed, I guess. So, yeah. So s prime of t is equal to vt, actually, where vt, velocity. And, yeah, it's pretty much all the same stuff here, except it's, like, moving to the left, moving to the right. Okay, and then s double prime of t is equal to v prime of t, which is equal to a of t, where a of t is acceleration. I'm sure you know this already. I don't know why I'm talking to myself. Okay, that's essentially how it is. So let's do a practice question, which, yeah, it's right here. Should change to a darker color. Let's do, oh, that's such a pretty navy blue before what happened. Do this black. Okay, so you have this equation here, right? You want to find the velocity and the acceleration at time t. So this is essentially saying you want to find s prime of t, and you want to find s double prime of t. Oh, writing in black is so crisp. Okay, so s prime of t you can find, okay, that's 6t squared minus 30t plus 36. That's really lopsided to 6. So this is your velocity, effectively. And if you want to find s double prime of t, you just have to take the derivative of the derivative. So s double prime of t would be 12t minus 30. So this is your acceleration. Cool. So find the initial conditions and interpret their meanings. I'm assuming they want me to find the initial conditions of, like, everything. Hold on. Okay, yeah. But I kind of don't want to. Do I really have to? Ugh, I guess so. Okay, well, the initial conditions of something is essentially when you set it equal to, see here, set, oh, it's black. This is your initial condition, so s of 0. Where am I? Okay. So here, if you want to find the initial condition of position, you would have -22. Okay, and this essentially means the negative doesn't really matter. Like, you can, it's not like you can have like negative position. It just essentially means that the position is less than 0, so the position to left of origin. I know. Right. Very cool. Okay, and now you have v at 0, which you can tell is 36. So this is speed. Well, what was I supposed to say about this? It's initial speed. Hello. Am I even? Oh, okay, here it is. Yeah. Speed is 36. And then a0 is just 30. So acceleration. That's whatever. Okay. So to find the average velocity and acceleration, you can use s of t. So you want to find s at 2, because that's over here, right? When you sub it in, you eventually get 6 after like subbing it into all of this, which I'm too lazy to do right now. But yeah, that's essentially what you get. And then when you find s at 4, you get 10. And if you want to find the average velocity, you should, average these two. So average velocity is 10 plus 6 over 2, because you're dividing it. So you have, oh sorry, not 10 plus 6, 10 minus 6. And then you have 2 meters per second, which is your velocity, your average velocity. And then to find acceleration, you just do the same thing with v. So what you want to do is, yeah. So v of 2 would be, it's 24 minus 60 plus 36, 0. And then v to the 4 is 6 times 16 minus 30 times 4 plus 36, so it's 12. Okay, that took a lot longer. So the acceleration is 12 minus 0 over 2. So that's 6 meters per second squared. And that's essentially it. And okay, when they ask you when the particle is at rest, it means that your velocity is equal to 0. This is essentially what they're asking you. It's very important to know what they're asking you. I say is I don't know what they're asking you half the time. But yeah, this is essentially how it goes. So you have v of t is equal to 0, right? So that means you have 6t squared minus 30t plus 36 is equal to 0. Now you can factor out the 6 here. So you can have t squared minus 5t plus, what do you call it? 6, yeah. And then you can factor this very briefly. So you end up with 6t minus 3, t minus 2 is equal to 0. So this means that the zeros are where the particle's at rest. At rest, there's 2 places. At t equals 2, positive 2, and 3. Yeah, that's essentially it. And so when does the object move in a positive direction? So now this is where you want to pull out your interval tables, okay? So you can take this, and you put it into an interval table. So t minus 3 is 1. T minus 2 is another. Bro, please, straight line. Okay. And at the bottom, it's just s of t. Or no, v of t, sorry. So obviously the limit here is 0. You can't go to like negative infinity like you could sometimes. Then one of your zeros here is 2. The other is 3. It's important that you go in numerical order, by the way. And then you can go to positive infinity. You can go however fast you want. I just don't recommend it. Okay. So now what we're looking at here, if you put any number between 0 and 2, so for example 1, right, as the value of t, 1 minus 3 will be a negative number. So we will put a negative here. And this could be any other number. It could be like 1.5 minus 3, and that'd still be a negative number. And now anything between 2 and 3, think about it. Okay. So if you were to do, if you were to put 2.5 minus 3, you'd still be 0.5 short, you'd still be negative, so here. But anything between 3 to infinity, like 40 something minus 3, that'd be a positive number, so you put positive here. Do the same thing with here, and it's that, it'll end up being like this. And then the final bit at the bottom here, you see what these do. So a negative and a negative make a positive, so this will be positive. And, oh, that one way, okay, this will be negative, and this will be positive. So this is what we're looking for, okay? It's asking, the question's asking, when does the object move in a positive direction? So this, you could write with proper form, you would say that between 0 and 2, union 3 and infinity. And of course, infinity is non-inclusive because you can't include infinity. So these are the intervals at which the particle moves in positive direction. Yeah, that's basically it for derivatives because I don't want to do implicit differentiation today. Goodbye.